Today, we are going to move into solving quadratic equations by using the quadratic formula. So yesterday we wrote down the derivation of the quadratic formula, but today, before we get to use the quadratic formula, we will be deriving it one more time. So we divided by a on our first step to derive this quadratic formula. Next, Sierra.
Subtract c over a from both sides.
So we would now have x squared plus b over ax equals negative c over a. Sarah.
The next step would be to put b over a over 2. So,
Which will give me?
b over a times 1/2 squared equals b squared over 4a squared.
Which I add to both sides. What am I going to do on this right-hand side?
Multiply it by 4 so you get the denominator the same.
I will multiply it by 4a, 4 and a. So by multiplying c over a by 4a over 4a, that will give you negative 4ac over 4a squared plus b squared over 4a squared. They have a common denominator, so what's going to happen, Schweib?
You add combined lengths under add.
So we will get b squared minus 4ac over 4a squared. And now on the left-hand side, I can write that as a binomial that is being squared, since it is in perfect square trinomial form, which is what, Talon? Good. We have b over 2a squared. At this point, now that we've gotten this far in the quadratic formula, we're going to continue with the quadratic formula. And I'm going to shrink that down a little bit and move it on up. To finish this, we'll do what, George? On the left-hand side, you'll be left with x plus b over 2a. Renee, on the right-hand side, what will we have?
Plus or minus the square root of b squared minus 4ac over 2a.
Good. That denominator did, in fact, have a root. Natalie, what will I do to finish this off?
You're going to subtract b over 2a.
And that will give you x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's do these two, all right? I've got 3x squared plus 7x minus 4 equals 0. I wouldn't want to factor that, and completing the square on that looks like I'm going to get some really interesting fractions, because when I divide by 3, I'm going to have 7/3. And then I'm going to have to divide 7/3 by 2, and then I'm going to have to square that to complete this square. But let's look at what using the quadratic formula would look like. It's already set equal to 0, so I have a is 3, b is 7, and c is negative 4. Since I have the quadratic formula right there, I'm going to use it. X equals negative of 7 plus or minus the square root of 7 squared minus 4 times 3 times negative 4 all over 2 times 3. Only numbers here. It's multiply, subtract, add, divide, whatever you need to do, and then simplify at the end. That would be negative 7 plus or minus the square root of 49 plus 36. That is not 36. That is 48. Sorry about that. All divided by 6. That becomes negative 7 plus or minus the square root of 97 divided by 6. There is no simplifying available to us here. We are done. We didn't have to complete a square. We didn't have to move stuff from right to left. We didn't have to try and figure it all out. It's just plain done. Go ahead and try that one on your own. The discriminant comes directly out of the quadratic formula, which is where we are headed next. It is b squared minus 4ac. And the cool part about the discriminant is this. It allows you to tell how many solutions your graph will actually have. How many solutions will the quadratic possess? And there's three possibilities. There are either two real solutions, one real solution, or there are two complex solutions. And it's actually very easy to figure it out. Here's your table. There are two real solutions if your discriminant is positive. There is one real solution if your discriminant is 0. And there are two complex solutions if your discriminant is negative. Let's unpack this here real quick though. The way it works is really simple. If b squared minus 4ac is positive, the quadratic formula has plus or minus the square root of b squared minus 4ac in it. So if it's positive, then I should have a positive and a negative square root. That's a positive value. Well, that would change it both to the positive and to the negative, so how many solutions would that have? If it is one real solution, it's because the discriminant is 0. Look what happens. If I have a 0 for b squared minus 4ac, I'm going to have plus or minus the square root of 0. Well, 0 just goes away at that point, doesn't it? And you end up with negative b over 2a. You have one solution. Finally, we have two complex solutions when b squared minus 4ac is negative. Because if your square root is a negative radicand, that's the inside of the square root. So if we have a negative radicand, then you always have an imaginary number value. Because you can't take the square root of a negative unless you use the imaginary number, which forces us to have complex numbers because there would be a real part, and then you would have that root imaginary part.